Hi everyone. I'm going to be going over Leetcode problem 2064, minimize maximum of products distributed to any store. So let's just read the description together. You're given an integer n indicating there are n specialty retail stores. There are n product types of varying amounts, which are given as a zero index integer array quantities, where quantities I represent the number of products of the ith product type. You need to distribute all the products by the following rules. A store can only be given one product type of any amount. And after distribution, each store will be given some number of products. Let X represent the maximum number of products given to any store. You want X to be as small as possible. And if you just look at the first example right here, we can see the quantities 11 and 6, and n is equal to 6. And the way you're basically going to be dividing these numbers right here, right? You're going to be dividing 11, you're going to be dividing 6, right? So the way they have it here is 11 product types, and you can distribute to the first 4 stores. So if you did 11 divided by 4 and then rounded it to like integers, you would have 2, 3, 3, 3, and then you could divide 6 by 2, and then you would get 3, 3, 3 right here. And then the maximum number of products given to any store would be 3, right? And just as the second example, right, we can see that n is equal to 7 here, and then 15, 10, 10, 15 divided by 3, you get 5, 5, and then 10 divided by 2, 5, 5, and the maximum is 5. So basically what you're doing is you're basically dividing the numbers that are in here so that the amount of items is equal to this, and you want to minimize the maximum number that you're going to get after dividing all these numbers. So now that we just kind of went over that, I'm just going to take a look at the drawing explanation, right? Okay, so this is going to be the drawing explanation of this. And I wrote down our, from the second example, 15, 10, 10, that was our input array, and the number of stores we had here was like 7, right? And so, and the answer that we're going to be expecting would be 5. And I mentioned dividing, right? We're always going to be dividing the biggest number here, right? It doesn't make sense to distribute the tens first, right? If we wanna basically minimize the biggest number in this array right here, that number is going to be 15. And the way we're going to do that, and that first key intuition is going to, and that came to me first, by the way, is we're going to be using a max heap, right? We're going to be using a max heap. We're going to be using a max heap. If you don't know what a max heap is, it's just a data structure that is every time we're going to pop from it, it's going to give us the largest possible value. And the next second key intuition right here, the second key intuition is that we're going to, when we're dividing, right? When we're dividing, it's always going to make the amount of the amount of items here increase by 1. So if we divided 15 by 2, and I just wanted to put this back into like whole integers, right? It's going to be 8 and 7, right? Because 8 plus 7 is going to be equal to 15. And then if we just took a look at our array right here, it's going to be 10, 10, 8, and then 7, right? That's pretty simple. And then the amount of items we have here our numbers is 4. So we divided it by 2 and it went up by 1. And if you think about it here, right, if we divide this number also by 2 and we divide these two tens by 2 right over here, it's also going to go up by 1. And if you just we take a look at what that's going to be, right, that's going to be sorry, technical difficulties there. Just erase that little scribble right over there. That is going to look like this. It's going to look like this. 8, 7, and then if we divided those two by 5, it's going to be 5, 5, and then 5. And that is going to be in total, right? That is going to be 6 items right there. So essentially, it's going to, if we divide it by 2, right, it's going to come from 1 piece, 2 pieces. It's going to increase items by, well, the divisor minus 1. And so the amount of divisions that we're going to do, and maybe this may not be clear at first, is it's going to be n minus m, which is m would be the amount of items that we started with, right? So m in this case would be equal to 3. So in this specific example, it would be 4. And now, stop thinking about integers. We're going to be thinking about ratios for a second now. If you divided 15 by 2, right, you can't really simplify this fraction. If you wanted to look at it as a decimal, you could think of it as 7.5, right? You can think of it as 7.5. And now that it's at 7.5, you've basically increased the amount of items in the heap. So now it would now be 10, 10, 7.5, 7.5, right? It would be 7.5. It would be these two, and now we have 4 of them, right? But the way we're going to code this up is we're not going to like pollute our heap with these two like 7.5s over here. What if we can just keep track of 3 things? We're going to keep track of 3 things, right? We're going to keep track of the number 1, the ratio, right? The ratio, right? In our example here, it was 7.5 or 15/2, whichever you want to think about. And then number 2, we're going to be keeping track of what that like original number was. So the original number here in this case was 15. So I'll call this n, and n is going to be 15, right? And then the third thing we're going to be keeping track of is the divisor, right? The divisor, right? And that would be in this case, right, 2. So we're gonna have our array our heap rather. Our heap is gonna look something like this after that. So 10, 10, and I'll just put this like fraction right over here. 15/2, right? 15/2, right? And then that's kind of how we're gonna process it. And so at this point, let's keep our like little so this would be after 1 iteration, right? That would be after 1 iteration. I'm gonna write down 4 right over here. If we keep going, right, if we divide these two 10s by 2 over here, we're gonna end up with an array that kind of looks like this, right? We're gonna have something that looks like 15/2, 10/2, 10/2, and we've done this 3 times. We started with 3, right? It's gonna be 6, right? And now we can basically this is 7.5, right? 15/2 is 7.5, right, is bigger, right? Is bigger than 5. So we just simply divide this one more time, right? And then we're gonna end up with an array that just simply looks of just a bunch of 5s. Just 5, 5, because 15 divided by 3 is 5, right? 5. Yeah, I'm kind of running out of room here. So, or in our more like compact way of thinking of it, it's going to be 15, 3, 10/2, and then 10/2. And now that we can like think about it that way, the smallest number is fairly obvious here. The smallest maximum number that we can get is going to be 5. So I'm going to go on to the coding explanation. Everything should just click if it hasn't made sense to you yet. Okay, so I'm going to get into the coding explanation of things. And so I'm going to be putting a tuple to my max heap. And I'm just going to really make it clear what I'm putting in there. I'm going to be putting the ratio, the original number, and then the divisor, right? And the divisor is just going to start out with 1. And so this is going to be my max heap right here. I'm going to be using list comprehension tuple. So it's going to be -q because Python out of the box only supports min heaps, not max heaps. So making it negative will just make it max heap. So we're putting our original number right there, q, and then the divisor 1, right? Since we haven't really done any division, and any number divided by 1 is just itself. So for q in quantities, right there's our little list comprehension, nice and clean. And I just mentioned earlier that the amount of times we're going to be doing this division is just going to be n minus the amount of items. We'll just call it m, right? And so and the underscore just means it's not really like relevant in the loop. So we're going to be doing our loop n minus the length of quantities, right? And so let's pick up from the heap. So ratio. This is unpacking right here. So n divisor, and that is just going to be heap, heap pop, max heap. Also, I forgot to heapify this, so let's just do that right over here. Heapify, max heap, and we'll keep that and paste it right there, just so that's clear. Okay, so what are we going to do now? We're going to increase the divisor by 1, right? And we're going to calculate the new ratio. The new ratio here is going to be, we're gonna have to multiply by -1, right? Because when we put the original number and the divisor, they're both positive. So negative, and then put it in parentheses right here. N divided by the divisor, simple. And now we're going to push it back onto our heap. So heap push, specify our heap, max heap. And then the item, and we're going to make this tuple right here. We're going to put our new ratio. We're going to put the original number we got. And we're going to put divisor. I forgot the parentheses, the comma right here. And that's pretty much it. The next step here is just going to simply be, let's just put ratio and it doesn't really matter too much, and divisor. And let's pop from the heap. Heap pop, max heap, easy peasy. Return, we're going to just take our, we're just going to take the ratio and we can multiply it by -1. And that's it. If we just run that. Oh, let's make it, we actually forgot one thing right here. Honey? Okay, there we go. Okay, so we're going to actually do the sealing. Math seal. And the reason is because we could have something like 5.5, and that will become 6 and 4, right? Because we're going to be, you can't give 5.5 to a store. That's not possible. It's going to just go to that, right? So like, or let's say, not 6 and 4, 6 and 5. Like if we divide it, for example, 11 by 2, right? Just an example. So yeah, so, and then the ratio times 1. And there we go. And that's it. It's, I'm not gonna lie, the intuition isn't like the easiest thing in the world, but it's not too bad. And if we submit it, bada bing, bada boom. So if you liked this video or found it helpful, be sure to share. Thank you.